Hello, I'm Berge Jololian, and this is my final project, a serverless Gen AI RAG assistant for MediClinic. The idea is simple. Staff can upload official standard operating procedures, PDF files, and then ask questions in plain English. The system answers only based on those SOPs, and it shows exactly which documents and sections were used. Under the hood, it's a small, fully serverless architecture on AWS using S3 for storage, API Gateway and Lambda for compute, DynamoDB for metadata, and Amazon Bedrock for the AI side. In a hospital environment like MediClinic, frontline staff rely on standard operating procedures for safe care, pre-op fasting, sedation, checklist, infection control, and so on. In practice, these SOPs live in different folders, shared drives, or systems. When someone asks, what's the pre-op fasting protocol for pediatric patients, for example, it can take a while to find the right document and then the right page. That slows decisions and can lead to inconsistent answers. My goal in this project was to prototype a small assistant that always points back to the official SOP documents, not random web content and not someone's memory. Uh, From the user's perspective, the app is deliberately simple. At the top, there's a banner that explains the demo flow. Upload SOP, ingestion runs, ask a question, view answer and sources. The first card lets you upload a SOP PDF. The second card lets you ask a question in normal language. When an answer comes back, the UI shows it in the answer panel, and then it shows the sources used section. That's a bullet list of the specific SOP files and chunks that were consulted. This is what makes it a RAG assistant, not just a generic chatbot. The high-level architecture that we see here, the front end is a static HTML JavaScript site hosted in an S3 bucket. When you click Upload or Ask, the browser calls on an AWS API gateway, HTTP API. There are two post routes. Upload URL, a lambda called MediClinic RAG upload URL that hands out a pre-signed S3 URL so the browser can safely upload PDFs. And a RAG query, a lambda called MediClinic RAG query that runs the retrieval augmented generation pipeline. Now for RAG, the lambda talks to DynamoDB, where I store SOP chunks and their embeddings, and to Amazon Bedrock, which provides both the Titan embedding model and the Claude S3 Sonnet language model. The web app itself is just two main files, the index.html and the app.js, both stored in an S3 bucket that's configured for static website hosting. Index.html defines the layout, the banner, the upload SOP PDF card, ask question card, the text box, and answer panel. It also wires up the chips, those little buttons like pre-op fasting or medication safety that autofill example questions. And the app.js is the brain of the browser. It listens for clicks, reads the selected file, calls the upload URL API to get a pre-signed S3 URL, uploads the file, and then calls RAG query when the user clicks ask. It also updates the UI with states like thinking, which is a nice touch, and builds the sources used list. Originally, the upload button was just a placeholder. It did nothing. One of my big milestones was turning that into a real credential-safe upload flow. Here's what happens behind the scenes. When you choose a PDF and click Upload, app.js sends a post request to upload URL with the file name and MIME type. The MediClinic RAG upload URL lambda reads that request, constructs a key under an upload prefix, and calls an S3 to generate a pre-signed URL with put object permission for that file. It runs JSON-like upload URL statements, and then the app.js then does a second request, an HTTP put directly to that upload URL, streaming the PDF byte straight into S3. In S3, if S3 returns 200, The UI shows a green upload complete stored as uploads. That's a success. On the right, you can see the uploads folder in the docs bucket and the 4 SOP PDFs I used in the demo there. Now, the second key flow is the RAG query. When the user clicks Ask, the browser gathers the text from the question box and sends it as JSON to the RAG query endpoint. The MetaClinic RAG query Lambda does two major things. First, it uses an embedding model to present the question as a vector, then queries the MetaClinic RAG chunks table in DynamoDB for the most similar SOP chunks. Each row stores the document ID, the chunk index, the chunk text, and the embedding vector. Second, it then calls the Amazon Bedrock and passes top K chunks plus the question into clause 3 sonnet. The model is instructed to answer only using those passages and to include internal references, like a number 1, to the snippets. Finally, the Lambda returns a JSON object with both the answer and chunks array listing which document IDs and chunks indices were used. This is an example of an actual JSON response that we see here. The answer field is what you see in the big answer box. It's already nicely formatted English with internal references. The chunks array is the evidence. Each entry tells us which document the model used and which chunk index within that document and a similarity score. I use that metadata on the front end to build a sources used bullet list. For example, one line might say, I think it says PET pre-op v4 chunk 0 or uploads PET sedation checklist version 1 chunk 30. That's how we can show exactly which SOPs the answer came from. Now, this is really the heart of the project, answers that are traceable back to the official SOP text. To ground this in actual AWS resources, here are the two S3 buckets. The first bucket, MetaClinic RAG site, hosts index.html and app.js. This is where the web app lives. It's just a static website, no servers to maintain. The second bucket, MetaClinic RAG docs, holds the SOP content. I have a text file there, pets pre-op v4, which simulates the pre-chunked content and an uploads folder where the new PDF SOPs land using the pre-signed upload flow. A separate ingestion process, which can be a Lambda or a step function, reads from this docs bucket, splits the files into chunks, builds embeddings, and writes those into DynamoDB table. Here you can see the IAM role for my upload Lambda. I added a custom policy called MetaClinic RAG docs put object that allows only S3 put objects to the MetaClinic RAG docs. That means the function can upload SOP PDFs, but it can't read or delete anything else. I wanted very much to do a live demo, but I had technical difficulties with embedding it in the slide here. So I phrased it here in the slide. When uploading a file, the browser is not sending the file directly into S3 with any hard-coded credentials. Instead, it calls the upload URL API, which asks Lambda function for a one-time pre-signed URL. That URL is temporary secure upload ticket. The browser uses that ticket to put the file straight into the SOP doc bucket, as we had mentioned previously. Then you have the second part is the ask question. Behind the scenes, the browser sends the question to the RAG query API. The MetaClinic RAG query Lambda looks up the most relevant SOP chunks in DynamoDB, calls Amazon Bedrock to generate a short answer, and sends everything back as a JSON. You can see the upload complete success message on the number 1, and you can see how there's a question asked with a field there where there's a question is posed. On the third panel, you have the answer panel, shows natural language response that the model produces. And just below, there is a source section with each bullet shows exactly which document and chunk were used. The answer is grounded in the uploaded SOPs. Uh, there were a few interesting challenges along the way. Naturally, there were challenges. First, I spent time chasing CORS issues and 404s from the API gateway endpoints. That forced me really to understand how routes, stages, and CORS headers work together, and it motivated me the improvement error messages in app.js like request failed, check CORS, and API URLs. Second, implementing pre-signed uploads took a couple of iterations. I mean, maybe more. It's easy to make a pre-signed URL that looks fine, but doesn't accept the browser's put because of mismatched headers. Testing the Lambda with sample events helped a lot. Third, I locked down IAM so that the upload Lambda has only S3 put object on the docs bucket. That was a good exercise in writing a small customer managed policy and verifying it in the console. Overall, the debugging process gave me much more hands-on experience with how serverless pieces actually behave in real workflow. To wrap it up, there are several natural next steps. For MediClinic, the prototype could be extended to more SOPs and more departments. Um, I'd also like to add visible ingestion pipeline with status indicators so we can see when a newly uploaded SOP has been chunked and indexed. And in a real deployment, you would add authentication and auditing to track who asked what. Uh, More broadly, this pattern, serverless practices grounded in internal documents, could be reused in many domains. It could be in IT runbooks, it could be in HR policies, financial manuals, and beyond. And finally, I want to say thank you, Professor Greg Mexico. Thank you for the clarity and guidance throughout the lectures. I really valued your lectures, and especially Marina Popova, Sergey Kovalenko, Anthony Bunker, and Hector Saint-Hilaire. Thank you for your enthusiasm, support, and encouragement in this section, meetings, and feedback. I generally appreciated the care you showed. This has been a wonderful experience. I thank you all. Thank you very much, and have a wonderful holiday season.